Good morning, ma'am. I am Hema from Computer Science and Engineering Department. Now, my topic is 0 by 1 knapsack problem using dynamic programming. Now, I am going to discuss about introduction, problem definition, dynamic programming approach, time complexity, space complexity, applications and their limitations, and then conclusion. Introduction to the 0 by 1 knapsack problem. The 0 by 1 knapsack problem is a classic optimization problem in computer science. It involves selecting items with a given weights and values to maximize total value without exceeding a weight limit. The problem is called 0 by 1 because each item can either be included or excluded from the knapsack. Included means 1, excluded means 0. So it is called 0 by 1 knapsack problem. Here we can see one example of the knapsack problem. Given W is equals to 40, W means capacity, N plus 3, value is equals to 10, 20, 40, weight equals to 30, 20, 20. Recursion tree for the above problem. We can clearly see that Fn of 1, 20 is calculated twice, thus overlapping subproblem property can be observed. Problem definition. Given a set of items, each with a weight and value, the goal is to maximize the total value of items in a knapsack. The knapsack has a maximum weight capacity which cannot be exceeded. The decision is made for each item whether to include it in the knapsack or not. Knapsack problem. Instance. Given a set of n items, each with a weight Wi and a value Vi and a capacity W for the knapsack. Question. Determine the count of each item to include in a collection so that the total weight is less than or equal to a given capacity of the knapsack. Computational complexity. NP hard means there is no known polynomial time algorithm that can solve this, and there is no algorithm that can solve this non-deterministically in polynomial time. Example scenario. Consider a knapsack with a capacity of 50 units and 3 items. Item 1 has a weight of 10 and a value of 60. Item 2 has a weight of 20 and a value of 100. Item 3 has a weight of 30 and a value of 120, showcasing the typical item characteristics. Consider the following items in the knapsack problem. Item 1 has a 3 weight and a value $3. Item 2 has a 4 weight and a value $12. Item 3 has a weight of 2 and a values $10. Item 4 has a weight 5 and a value $20. Given the knapsack capacity equals to 9. In fractional knapsack problem, what is the maximum value that can be put in the knapsack? The answer is $38. Dynamic programming approach. Dynamic programming is an efficient method for solving the 0 by 1 knapsack problem. It breaks the problem down into simpler subproblems and stores their solutions for reuse. This approach helps avoid the exponential time complexity of a naive recursive solution. Main efficient method is dynamic programming because it breaks the problem into subproblems and it solves the subproblems and store their solution for the reuse. It will reduce the time complexity. Dynamic programming. Dynamic programming is also used in optimization problems like divide and conquer method. Dynamic programming solves problems by combining the solutions of the subproblems. Moreover, dynamic programming algorithm solves each subproblem just once and then saves its answer in a table, thereby avoiding the work of recomputing the answer every time. Two main properties of a problem suggest that the given problem can be solved using dynamic programming. These properties are overlapping subproblems and optimal substructure. Steps of dynamic programming approach. Dynamic programming algorithm is designed using the following four steps. First step is characterize the structure of an optimal solution. Recursively define the value of an optimal solution. And the third one is compute the value of an optimal solution, typically in a bottom-up fashion. And the last one is construct an optimal solution from the computed information. 0 by 1 knapsack. In 0 by 1 knapsack, items cannot be broken, which means the thief should take the item as a whole or should leave it. This is the reason behind calling it as 0 by 1 knapsack. Hence, in case of 0 by 1 knapsack, the value of x I can be either 0 or 1, whether other constraints remain the same. 0 by 1 knapsack cannot be solved by greedy approach. Greedy approach does not ensure an optimal solution. In many instances, greedy approach may give an optimal solution. Transition formula for the 0 by 1 knapsack problem. The transition between states is defined by the formula if the weight of the item is I is less than or equal to W, then include it or exclude it. dp of I into W is equals to maximum dp of I minus 1 into W, comma, dp of I minus 1 into W minus weight of I plus value of I. This is the transition formula for knapsack problem. Time complexity for the knapsack problem. The time complexity of the dynamic programming solution is O of NW. Here n is the number of items and W is the total weight capacity of the knapsack. There is a significant improvement compared to the exponential time complexity of the recursive approach. Space complexity. The space complexity of the 0 by 1 knapsack dynamic programming solution is O of NW. However, this can be optimized to O of W by using a single dimensional array. This reduces memory usage while still maintaining the same time complexity. Applications of the 0 by 1 knapsack problem. The 0 by 1 knapsack problem has applications in resource allocation and budget management. It is also relevant in finance for portfolio optimization and investment strategies. Furthermore, it finds use in logistics such as cargo loading and shipment planning. There are so many applications for the knapsack problem. Mainly it uses the resource allocation and the budget management, and it is also used in the finance for investment strategies, and furthermore it used in the logistics for cargo loading and shipment planning. There are some limitations of the dynamic programming approach. The dynamic programming approach may still be infeasible for very large inputs due to its space complexity. It requires a clear understanding of the problem to set up the state transitions correctly. Additionally, this method is not suitable for problems where items can be divided fractional knapsack. There are so many limitations for the dynamic approach because it needs clear understanding of the problem for state transitions correctly, and it is infeasible for the very large inputs due to its space complexity. Here we can see the types of approaches. Dynamic programming is two approaches are there: top down approach and the bottom up approach. Top down approach used in memorization and bottom up approach is used in tabulation. Conclusion. The 0 by 1 knapsack problem is a fundamental topic in algorithm design and analysis. Dynamic programming provides an efficient way to solve this problem compared to brute force methods. Mastering this technique is essential for tackling various optimization problems in computer science. This technique is essential for tackling various optimization problems in computer science. This is all about the 0 by 1 knapsack problem using dynamic programming. Thank you. Hope you like it.